Okay, so this is the revision of the Johannesburg West District Gauteng Province mathematics paper that was written 2024. Right, so I want to just revise it quickly in preparation of the March control test. All right, I will quickly go into the revision, skipping the instructions for the sake of time, but I do advise when we are in the exam to go through them and understand them. It's very, very important. Like, for example, the instruction number 7, which is saying if necessary, answers should be rounded off to 2 decimal places unless stated otherwise. It's very important to understand that. So I will go straight to question number 1 there. Question number 1 is saying, solve for x. Right, I need us to understand that whenever we have brackets, right, the question is already half done. So what we simply do is say either x is equal to -2, taking the first bracket because x plus 2 should be equal to 0. So automatically x should either be equal to -2 or 3x is equal to 1. So dividing by 3 here, dividing by 3 here, x is going to be equal to 1/3. Right, so or x is equal to -2. That marks our 2 solutions for the first question. 1.2 is now saying, again, solve correct to 2 decimal places. So indeed, that's what our instruction says, to 2 decimal places. Right, so the first thing that we have to do is to arrange that equation into the standard form. So we are going to arrange it 6x squared minus x minus 4x minus 4 is equal to 0, taking everything to one side. Then, by so doing, we end up having 6x squared minus 5x minus 4 is equal to 0. Right, so once it's in standard form, it's now in the form of ax squared plus bx plus c. Once it is in that form, it means that we can now be able to solve it. We can solve using completion of the square. We can solve using the quadratic formula. I will opt for the quadratic formula. It's a little bit quicker. So a is equals to c, b is equals to -5, and c is equals to -4. By the way, in terms of being quick, any method, it depends with how acquainted you are to it. It's still okay. You can still do that. Okay. So in this case, using our quadratic formula, minus d plus or minus the square root of d squared minus 4ac. So of course, this might not be over 2a, might not be necessary. We are having it on the data sheet, right? So we can simply substitute now. A, b, that's negative, so that's -5 there, right? Plus or minus the square root of -5 squared, right, minus 4 times a, which is 6, right, times c, which is -4, right, divided by 2 times 6, divided by 2 times 6, right, and that is going to give us the first one, 4/3, which is the same as 1/3, or x is equal to, so we are saying x is equal to -1/2, having to punch it on the calculator, or we can present it as a decimal. This one we can write it as 1/3, it's still fine, right? Or we can write it as decimal 1.33 to 2 decimal places, or x is equal to -0.5. It's still fine to do that, right? So let's go to the next question. The next question is now saying, solve the inequality 2x minus 2 minus x bracket 2 x plus 3 is greater than x minus 2. So again, we need to arrange that into the standard form. So expanding the left hand side, 2 times 2x, that's 4x there. 2 times 3, that's a 6. We are done with 2. We go to to negative x. Negative x times 2x, that's negative 2x squared, right? Negative x times 3, that's negative 3x is greater than x minus 2. Okay, so I simplify before I take everything to one side. So I am 4x minus 3x there. That's x plus 6 minus 2x squared is greater than x minus 2. I'm just writing this stage here, but we can move along together because I want to take everything to one side. Now I have an option. I can take what is on the right hand side to the left hand side, or I can take what is on the right hand side to the left hand side. But if I work with a forecast of what is to come ahead, I see the highest degree of power is having a negative. It means I'm going to deal with a negative. So I can avoid doing so by taking everything to the other side. So I get 0 here is greater than. So I'm taking everything to this other side here. So that's minus x, this x here, plus 6, so it becomes minus 6, right? Plus 2x squared plus x, right? Minus 2. So this is what we now have, minus 2. By simplifying that, minus x plus x, that's a 0 there. Minus 6 minus 8, that's a 2 there. So I have 0 is greater than 2x squared minus 8. Right, then I see a common factor which is 2 throughout. I can divide by that common factor to simplify my inequality, just like how I do it with equations. So 0 is greater than x squared minus 4. So that's the inequality that I'm now supposed to solve, right? So as it is right now, if I write it like this, if I write it as x squared minus 4x is smaller than 0, I haven't changed anything because 0 is greater than x squared minus 4. It's the same as to say x squared minus 4 is smaller than 0. It's one and the same thing. There's no difference. Right, so what do I see here? I see a difference of 2 squares. So I have x plus 2 bracket x minus 2 is greater than 0. This is what I now have, right? So I now find the critical values. So my critical values are x is equal to negative 2 and x is equal to 2. These are the two critical values that I have. Then I go now and represent either on the number line or graphically. So I will opt to represent them graphically, right? Knowing very well that I do have the 2, that's negative 2 and 2 here. Right. So once I have done that, I now check for where the values that satisfy the inequality are found, because I have two positions now, this one and this one, or the middle part, which is this one. Right. So these are the two that I have. So I will pick any one to see if it satisfies the inequality. So I pick any value between minus 2 and 2. The easiest to work with is 0. It saves you a lot of time. So I just substitute 0 here at x. 0 minus 4, that's a minus 4. Minus 4 is smaller than 0. Is it true that negative 4 is smaller than 0? It's very true. Therefore, all the values between minus 2 and 2, they are the ones that are satisfying this inequality. It means, therefore, that I have minus 2 is smaller than x is smaller than 2, which means we are excluding the values 2, minus 2, and 2. So oftentimes, such a situation would best be indicated this way, right? So basically, this is what is happening within our inequality, right? Having done that, I go to 1.4. 1.4 is saying solve the equation again. I now have 3 exponent of 2x. right, minus 81. As a matter of fact, I do advise questions such as question number 1 there. Thrive to take all your marks in such questions. It's very much possible. Get used to the algebraic expressions, algebraic equations, dealing with equations and inequalities, dealing with exponential equations. It sets, because those are the questions that you are to meet there on question number 1. Okay, so there we are. 3 exponent of 2x, I'm taking everything to one side, minus 8 times 3 exponent of x. However, x plus 1, I see that it is the same as 3 exponent of 1. Right, so it's 3 exponent of x times 3 exponent of 1. It's one and the same thing as to say 3 exponent of x plus 1. Why? According to the laws of exponents, minus 81 is equal to 0. So what am I doing? I'm taking everything one side so that I create an equation based on the understanding that 3 exponent of 2x is the same as 3 exponent of x times 3 exponent of x. So if it is the same as 3 exponent of x times 3 exponent of x, this is nothing other than a quadratic equation, except that it is in exponential form. So I have two options. Either I can say let 3 exponent of x be equal to k, so that this 3 exponent of x times 3 exponent of x becomes k times k, which becomes k squared. I'm just writing that aside because I'm not going to do that. K squared minus, right here I now have values 8 times 3 exponent of 1. These are values, constants. I can multiply 8 times 3, I get 24. So I have now minus 24. Right, another 3 exponent of x, remember we've said let it be equal to k, so it becomes minus 24k minus 81. So we can see it's a quadratic equation in terms of k. Right, so we say it's equal to 0. We can solve it that way. Right, right. So we solve it just the normal way we solve quadratic equations. I'm not going to do that. I want to solve it directly the way it is, because we also ought to get also used to the understanding that it is just a quadratic equation, just like any other quadratic equation. We can solve it the way it is, knowing that this is the highest degree of power, 3 exponent of 2x. Okay, minus 24, 3 exponent of x. Okay, 24 times 3 exponent of x minus 81 is equal to 0. So this is our equation, the way it is. All right, so if this is our equation, let's now try to solve it the way it is. Okay, treating it as a quadratic equation, the way we understand quadratic equations, the way we understand that this, if it was k, it was going to be k squared. If this was k, it was still going to be k, like I was just illustrating the aside. Right, so how do we solve it? We know that we can solve a quadratic equation using either factorization or using the quadratic the quadratic formula and every other method. This equation that we see here can be solved by factorization. So our two factors, 3 exponent of x, right, and what else again? 3 exponent of x. So I'm looking now for 3 exponent of x. I'm looking for two numbers, to be precise, because they were actually supposed to be terms. Numbers which when I multiply, they will give me negative 81. But when I add them, they'll give me minus 24. So already those numbers, they are telling me that one of them is a negative, the other one is a positive. And of course, the bigger one should be the negative, because when I add them and they give me a negative, it means the bigger one between them is the negative. But I'm trying to explain in a way that we can relate or understand, but from the actual context, it's not the bigger value necessarily. It's just you trying to understand that I'm looking for numbers. The two numbers which when I multiply, they should give me a negative 81. So already one is a negative and the other one is what is a positive. So obviously the negative one is the smallest one, but I'm trying to make it be understandable. So of course, which are those numbers? That's negative 27 there. And what else? And positive 3. So such that if we add 27 minus 27 plus 3, we get a minus 24. But if we multiply minus 27 times 3, we get a negative 81. So there we are. So once we are here, we are faced now with a quadratic equation. Right, so we can now solve it as a quadratic equation. Right, there we are. Therefore, 3 exponent of x, 3 Okay, so that's 3 there. Exponent of x is equal to 27, or 3 exponent of x is equal to -3. Right, the moment we are reached this point here, this other one, okay, let me just write it nicely, it's -3. So this is -3, right? This other one here has no solutions, so we leave it there, or even write no solutions on this. It cannot go beyond that, right? But we can solve for this one. It's going to be 3 exponent of x is equal to 27, right? If it is quick, using the affect button on our calculator, if you're using the Casio calculator, if we just say 27, we find its factors, it's going to give us 3 exponent of 3. It saves us time if we can change it to that, to say, okay, 3 exponent of x. Okay, 3 exponent of x is equal to 3 exponent of 3. Therefore, x is equal to 3. We have determined the solution. That marks our solution, right? So it's one option. Option 2, if you are not quick to notice that 27 can be raised to the powers of 3, because once the bases are the same, it means the exponents are also equal. They are the same. So if that is not quick to notice, you can just solve using logarithms. Introduce logs both sides, and you can solve it. It still becomes very possible, right? Let's quickly go to the second question. To the next question. 1.4 is saying, so for x negative, the root of x minus 1 plus x minus 1 is equal to 2. But first things first, we can first arrange it in this way. X minus 1 is equal to 2 plus 1 minus x. And that will give us negative root of x minus 1 is equal to 3 minus x. So this is what we have. So at this point, we now square both sides, and in so doing, right, square this side, square also this side, everything, right? So in so doing, this becomes x minus 1. The negative squared is positive, root squared, it becomes x minus 1 without a square root sign, right, is equal to, right, we need now to expand this side, 3 minus x bracket 3 minus x. However, since it's a perfect square, there's an easier way, of course, of expanding, to say we simply square 3 squared plus the bottom we multiply, the middle we multiply by 2, times, we repeat them, 3 multiplied by negative x. So the two of them, 3 and negative x, we multiply them by 2. Then at the ends, we square them. We are squaring negative x squared. So you just mark that. Here you square, here you square, then here you multiply by 2. You multiply them by 2. Always, it has to be like that. So it becomes a quicker way of expanding. Minus 1 is equal to 9. 2 times 3 times negative 6 times negative x, that's negative 6x, right, plus x squared. So always this will be positive. That's how it will end up being, right? Which means we take everything now to one side to form a standard equation, a standard quadratic equation, right? So we are taking it to standard form. X squared minus 6x minus x plus 9 plus 1, right? And that will definitely give us 0 is equal to x squared minus 7x plus 10. So we are looking again for two numbers, which when we multiply, they will give us 10, positive 10, but when we add them, they give us negative 7. It means both of them should be negative, so that when we add them, they will remain negative, but when we multiply them, they will give us a positive. So those numbers are negative 5 and negative 2. So we are done factorizing. So I'm opting for factorization method. So they are minus 5 and minus 2. Therefore, x is equal to 5, or x is equal to 2. We go now for restrictions. Looking at this equation that we are having this side, at this point where we had arranged our equation, negative root of x. And let me just remove the brackets that I explained in the absence of the brackets, what I want to explain here. Right. At this point, in order for what we have on the right-hand side to be equivalent, so we are looking for any restrictions if they are there on our solutions. Do we have any restrictions whereby any one of the solutions might not be applicable to the solution, to the equation that we are having? We are saying 3x minus 1 should give us a negative value. That's what we are witnessing here at this point here. So we are saying that, so I'm going to use a different color to try and explain. 3 minus x should be actually smaller than 0. Why? Should actually be smaller than 0, so that should be smaller than or equal to 0. Why? Because we see a negative here, right? So because of that, so we are saying it should be smaller than or equal to 0. Right? So it means that in solving it, 3 is smaller than or equal to x, which means x is greater than or equal to 3. That's what it means, which means the value of x that we are looking for should be a value that is greater than or equal to 3. So among our solutions, we have to consider that. So this understanding should be gathered or should be within us even before we arrive at the solutions. We are looking for a solution that must be either greater than or equal to 3. So among our solutions, is there any which is like that? It means because of that restriction, 2 here is not applicable. So x is not equal to, is not part of our solution. So this is not applicable. Therefore, x is equal to what? To 5. And that becomes the solution to this equation. So it's very important to note the restrictions whenever we are dealing with an equation that is in set form, like what we're witnessing. Then simplify without using a calculator. Right, so this is what we now have. 5, by the way, this is a 3, so this is 3 times 5. Okay, this is a 5 exponent of 22 plus, right, 5. That's a 5, the exponent of 2024, right? So how do we deal with it? First things first, we check on the numerator. There is a common factor. Now, among all exponential expressions, like for example, I have x exponent of 8 and x exponent of 6. The highest common factor between them is x exponent of 6. And if I suppose factor out x exponent of 6, I am left with, so what I simply do, I subtract 8 minus 2. I'm left with x exponent of 2 plus 1. That's what I get if I have this as an expression and I want to factorize it. So it's important to have that idea in mind that I'm just explaining right now in passing. So we are to do the same thing there. Right? Noticing what we have there, it means that we have we are having the highest common factor is 5 exponent of 2023. That's the highest common factor among the numerator. Bracket, factor of what? So I simply say 2025 minus 2022. I get a 2. So that's 5 exponent of 2. Right. Plus, right, 5 exponent of 2022, just subtracting 2023 minus 2023, I get a 0. So 5 exponent of 0, that's a 1. So I'm left with plus 3 here, times 1 it's going to remain as 3. So this is what I now have. Bracket over, right, I do the same again on the numerator. The highest common factor there is 5 exponent of 2022, right, bracket 3, right, plus 5 exponent of 2. What's happening? 2024 minus 2022, I get a 2, right? And the 2022 minus 2022, I get a 0. 5 exponent of 0, that's a 1, right? These are now like variables. Here, 5 squared plus 3. This is just one value. It is the same thing. So without even simplifying, there's no need even to evaluate it or simplify it. You just have to say, okay, 5 squared plus 3 into 5 squared plus 3, that's a 1 thing. So if what I'm doing is not kind of visible, add it. 5 squared, that's 25 plus, that's a 28. 3 plus 5 squared, that's 28. 28 divided 28, that's a 1 thing, right? Then we are now at 5 exponent of 2023 divided by 5 exponent of 2022. Division tells us that we simply subtract the exponents. 2023 minus 2022. So that will give us 2022. That will give us 1. So 5 exponent of 1, that's a 5. So our answer becomes a 5. We've simplified it further than what is supposed to be, right? So that's how we were supposed to do it there. But moving on to the next question. Solve for x and y simultaneously. If 9, 1, right? So what do? We first deal with this first equation here, right? How do we deal with it? Right, so this is what we do. We simply first express it in a exponential form. What is it giving us? 9 exponent of y is the same as 3 exponent of 2 times y that we already witnessed. We end up having 3 exponent of 2y over 3 exponent of x. What are we trying to do? We want to make our bases be the same. Same applies with 27. It is the same as 3 exponent of 3, right? So once we have done that, here the bases are the same and we are subtracting. So what do? We subtract the exponents. 2y minus x is equal to 3 exponent of what? Of 3, right? So we have 2y minus x is equal to 3. This is what we now have, right? So that's now an equation, but it is still having 2 unknown variables. Therefore, we now have to solve it as a quadratic simultaneous equation with the other equation that we are having. So it marks our equation number 1. There is our equation number 2. So we solve them. So how do we do that? By targeting the linear equation, which is the first one. So what do we do with it? We make either y or x the subject. So in this scenario, it's kind of easier to make x the subject. So 2y minus 3 is equal to x. We've made x the subject. Then we take it and substitute into the other equation. Wherever there is an x, we are now substituting with 2y minus what? Minus 3. So let's now substitute x squared becomes 2y minus 3 squared, right? Plus y squared minus 15 is equal to, so we are saying wherever there is x, we are substituting with 2y minus 3. So we get again minus 5 there, right? Bracket 2y minus 3, right, times y. Okay, so having done that, so now expanding quadratic expression of this nature, it's now getting a little bit easier. I've tried to explain it there. So we simply say 2y bracket squared, then plus 2 times, we repeat, 2y times negative 3, right? So that's times negative 3 there, right? Plus negative 3 squared. There we are, negative 3 squared, right? There we are, right? So plus y squared minus 15, right, is equal to, we can expand again here, negative 5 times y times 2y, that's negative 10y squared. Negative 5 times negative 3 times y, that's positive 15y. Right, simplifying the left-hand side, it means it's going to give us 4y squared, right? 2 times 2y times negative 3, that's negative 12y, right, plus 9 minus 15, taking everything to one side, plus 10y squared, right, plus, that's also minus 15y, right. Of course, there was again y squared minus 15 here. I was supposed to include them, so I'm including them here. Plus y squared minus 15 is equal to 0. There we are. So everything now is taken to one side. So what is the next important thing? Adding everything. So we could have just added first the left-hand side, simplifying the like variables. Then we now take what is on the right-hand side to the left-hand side. All roads, they still lead to Rome. It's very important always to be accurate nonetheless. So we have 4y squared plus 10y squared plus y squared. These are like variables. So what does that give us? That gives us 15y squared. So that marks 15y squared there, right? Minus 12y minus 15y. That is giving us, that's minus 12, minus 12, minus 15, that's minus 27. Right, so that's minus 27y there. Right, then 9 minus 15 and minus 15. Right, so that's okay. I was having that's a 9 there, minus 15, and again minus that's minus, okay, this was just 9 minus 15. I think I repeated values here. It's not supposed to be another, right? This is just 15. We're already having it. It's here. There it is. We had indicated it. Sorry for that. There, it's already here. There it is. Right. So it's just simplifying directly. 9 minus 15, and that gives us minus what? Minus 6. Right. So our equation therefore becomes 15y minus 27 minus 6 is equal to 0. There marks our equation. So we already had the minus 15. What we didn't have was the y squared. So it is the one that we were supposed to include here, and is equal to 0. That marks our equation there, right? So having done that, what is the next thing now that we're supposed to do? We can solve it directly using the quadratic equation. It's still fine. Or we can see that there's a common factor here. We can reduce it first. Divide by the common factor, which is 3. If that is visible, it's good. But if it is not, just solve it directly. You can still arrive at the answer. Divide by 3, divide by 3. Right. So I advise that questions like this, perfect them to collect your marks and get all your marks. Right. So 3 into 15 there, that's a 5. So we have 5y squared minus, okay, the 3 into 27 there. Of course, just punching that on the calculator, minus 9y minus 2 is equal to 0. That's the equation we are now working with. Right, so using the quadratic formula, where we are saying a is the 5, B is the -9, and suppose we are still minus 27y minus 6 is equal to 0. We can solve it whereby you are now saying, where you are saying A is 15, right? That's 15 there for A. And B is -27, right? That's -27. And C is -6. You still arrive where you are substituting directly minus B, that's minus 27, plus or minus. So I'm just saying, assuming that you didn't see the factors, by factorization you can still solve the same equation, and again by simplification you can still solve the same equation. Even without doing that, you can still solve that equation. So we have negative 27 squared, okay, minus 4 times, that's 15 there, times -6, right, divided by 2 times 15 there, right, just so without simplification. So what are we getting? X, by the way, so this is going to be y as a matter of fact, because remember our equation is in terms of y. So this is y. So it means y is equal to the first value that we are going to get is, of course, if we punch that on the calculator, that's a 2, or y is equal to -1/5, or 0.2. So we have 2, -1/5, right? Right, having done that, or 0.2, we now take them one by one, substituting them into our equations. Remember, we had already made x the subject. X, we saw that it's equal to 2y minus 3. So we manipulate, or we take advantage of this equation here. Substitute 2 times 2 minus 3. That marks the first. Or y is equal to 2 times -1/5 minus 3. Right, so that will give us, okay, and that is going to give us x is equal to 1 for the first equation, or x is equal, or x is equal to, by the way, this is an x is equal to 2.6. Here we are. That marks our equation. Right, so our solutions are 4 of them. Y is this, when x is equal to this, and y is that, when x is equal to that. Will still be fine. Right, so having done that, let's go to the next question. Right, the next question is question number 2.3. The roots of a particular equation are given by x is equal to, determine the values of p for which these x values will be non-real, right? So which are those values? Right, for non-real values, the delta, which is b squared minus 4ac, should be smaller than 0. So in order for delta to be smaller than 0, it means that everything that is another square root sign there, 16 minus 4p times -p plus 5 should be smaller than 0. By so doing, we have formed a quadratic equation which we need to expand, a quadratic inequality, sorry, which we need now to expand. 16, okay, -4p times -p, that's a 4p squared, right? -4p times 5, that's a -20p, is smaller than 0. So we can now arrange it. 4p squared minus 20p plus 16 is smaller than 0. Now in this case, we can easily see that the common factor here is 4. I always advise where it's possible to simplify, do simplify, and work with simplified. So we have p squared minus 5p plus 4, right, is smaller than what? Than 0, right? So by factorization, it means it's possible to use factorization in this case, right? Two numbers which are there, when you multiply, they'll give you a 4, but when you add them, they should give you a -5. They are -4 and -1. So the critical values, looking at our critical values, P is equal to 4 or P is equal to 1. These are our critical values, right? Representing again where we are saying which are those values of P. We already have our equation there. So we want now to ascertain which ones are the ones that are satisfying the inequality that we are having there, right? So looking at that, so we have 1, we have 4 here. So picking any value in between 1 and 4, 2 can do, and we substitute. Or even picking any that is outside is still fine, maybe 0, but if it doesn't, it means the values that are outside are not going to be satisfied. So looking at 2, we can now take here and substitute. 2 squared, that's a 4, minus 5 times 2, that's a 10, 4 minus 10, that's a -6, plus 4, that's a -2. So -2, I am substituting 2 squared minus 5 times 2 plus 4. I want to monitor, is it really smaller than 2, what I will get? So I punch this on the calculator, I will get a -2 is smaller than 0. Is -2 the answer I'm getting smaller than 0? Is true. So it means wherever I picked 2, it's the part that is satisfying the inequality, which means this middle part here is the one that is satisfying the inequality, right? So therefore, I will simply say the values of P should be 1 less than P less than 4. There we are, right? I need us to also have in mind that the moment we are here, we have nothing other than an inequality right here at this point. We have nothing else other than an inequality, so we have to deal with it just like any ordinary inequality that we know. How do we deal with inequalities? As a matter of fact, it's one of the reasons why we ought to understand inequalities in general as a topic, because we can have them applying or being applicable to situations like the delta, where we can use, where we need non-real roots. Right? So this is what has happened. Let's go to the next question. We are now on question number 3, right? Question number 3 is saying, right, if cos 24 degrees is equals to k, determine the following in terms of k. Cos 336 degrees, right? These are trig identities, and our understanding of the reduction formula is being put into test, right? So we want now to apply that. Cos 24 is an acute angle between 0 and 90. So we need first to express cos 360 using the reduction formula on our cast diagram to say in which quadrant does 336 lie? 336 lies in the 4th quadrant. And in the 4th quadrant, we know that we have, if we go via the anti-clockwise direction, we have 360 minus theta. Of course, if we go in the clockwise direction, we also have negative theta in the 4th quadrant. Okay, so we want to express it, since it's already showing that it went via the anti-clockwise direction for us to end up having that 336. It means it has to be in the form of 360 minus theta, where theta is an acute angle. And apparently, we try to now apply it, or we now try to represent it in that regards. So cos 336 is the same or is equal to cos 360 minus which acute angle do we have to subtract in order to get 336? We just said 360 minus 336. We get 24. So it means we have to say 360 minus 24. As a matter of fact, what we have written here has no significant difference whatsoever with this. So one and the same thing, right? So why are we doing that? So that we can now see the reduction formula, according to the reduction formula, which expression is best suitable or it can fit cos 336. So we have 360 minus 24, which is the same as, because cos 360 minus theta, according to the understanding again of the reduction formula, cos 360 minus theta is equal to cos theta. It is equivalent to cos theta. So it means, therefore, cos 360 minus 24 is equal to cos 24. It's one and the same thing. And apparently, cos 24, we have been told it's equal to k, which means, therefore, this is equal to what? To k. So cos 336 is equivalent to k. We have just determined our solution, right? It's one way of doing it. All right, let's go to the next question. The next question is saying, that's 3.1.2. It's now saying 1 minus sine squared bracket 1 minus 1 56 degrees. Right. First things first, before we do anything, I want to put clarity on the meaning of sine squared theta. Oftentimes, I see many candidates having a little bit of a challenge to interpret or to understand that. I need us to understand that, number one, this is not the same as sine theta squared. It's not the same. Rather, it is the same as sine theta bracket squared, which means it's sine theta times sine theta. This is the same as that. Okay, so it's very good to note that. Okay, so in the meantime, I will express that way so that we can move along together to see why am I going to do what I'm doing, right? So that's negative 156, right? 156 bracket squared. This is what we have, bracket squared, right? So the next thing that you can do is, whenever you are dealing with negative angles, you have two options. You can either just add 360 onto them. So by that I mean you are simply going to do this, proceeding from here. You are simply going to say 1, right, minus, right. I want to do away with the negative, so I simply add minus 156 plus 360, right? Why is it so? Because minus 156 is going in the clockwise direction. It's going in this direction. So I just want to know its equivalence when I go via the anti-clockwise. Because more or less, it's quite easier to deal with positive angles than negative angles. But nonetheless, it's still important to get used to both of them. So here's what we have just done. Add the 360, right? So once you do so, bracket, mind you, it's still bracket squared, right? Right, so 1 minus, so this will give us minus 156 plus 360, I get sine 204. Right, so instead of dealing with minus 156, I'm now going to deal with 204. Right, so 204, in which quadrant is it found? 204 is gone, is above 90, above 180, but below 270, so it's in the third quadrant. So in the third quadrant, I know that sine is negative there, and I'm going to express it now as 1 minus, so it's sine, right, 180 plus theta, because angles in the third quadrant are given as 180 plus theta. So 180 plus, which acute angle am I supposed to add to 180 in order to get 204? Apparently it's 24. So I have to add plus 180 plus 24 bracket squared. I'm now dealing with sine 204 in the same way that we dealt with cos 336, right? As considering that it's now in the what? In the third quadrant, right? So sine 180 plus 24, that's sine 180 plus theta, is actually equal to negative sine theta. So it's equivalent to negative sine 24. That's what it means, bracket squared. So we are still squaring. Right? The reason why I had to write my square in this form, that's the reason why I was digressing to explain there what it really means to say sine squared theta, right? So you can see now that even the negative that we are having here is still being affected by this square. So it has to be squared as well. So we end up having 1 minus squaring everything here. We end up having positive sine squared 24. But do not forget, we were having our negative here, right? So we have 1 minus sine squared 24. Now, 1 minus sine squared 24, according to the understanding of the square identity. Square identity says cos squared theta plus sine squared theta is equal to 1. If I use theta, or if I say cos squared A plus sine squared A is equal to 1, is one and the same thing. So making either sine squared or cos squared the subject, it means cos squared theta is equal to 1 minus sine squared theta. So taking that advantage, it means that this is the same as cos squared theta, which is cos squared 24, right? So 1 minus sine squared 24 is equal to cos squared 24. But here I have cos 24 being equal to k, meaning cos squared 24 is going to be equal to what? Cos squared 24 is also obviously going to be equal to k squared. So it therefore means this is equal to k squared, right? Method number 1. Method number 2 was, this is the only way we could have done it. We could have also said, number 1 minus sine squared minus 156 degrees. Right, we treat this as a beta, it's one angle, right? And since it's just one angle as beta, we are saying negative beta is found in which quadrant? In the fourth quadrant as we go in the clockwise direction. We are assuming, we are ignoring that it's 156. We are just taking it as if it's a beta, just one big angle, right? So if that is the case, then remember, this is the same as 1 minus sine, 1 minus sine minus 180, 156, sorry, bracket squared, right? So I am saying we are assuming that this angle, or we just treat this angle as if it's one big angle theta. So it's now as if it's found in the fourth quadrant. And in the fourth quadrant, we know that sine is actually negative. So it becomes negative sine 156. Now we deal with it like this. It's another way again of doing it. So we have now sine 156 with a negative. Why? Because negative sine negative theta is equal to negative sine theta. It's one and the same thing. That's what I'm trying to explain here. Sine negative theta is equal to negative sine theta. That's what has caused me to do what I've just done here. So I hope you are following on that. Right. So if that is the case, then it means therefore 1 minus, right? So I now deal with 156 in the understanding that I have. In which quadrant is it found? It's found in the third quadrant, in the second quadrant. Why? Because 156 is above 90, but it's below 180, so it's found in this quadrant. And in this quadrant, angles are 180 minus what? Minus theta, and sine is actually positive. So it means, therefore, it is the same as to say sine 180 minus which angle can I subtract to get 156? Which acute angle do I have to subtract from 180? Apparently it's 24 again. So it's 180 minus what? Minus 24. Right, bracket what? Squared. Not forgetting the square. Right, so I now deal again with the sine 180 minus 24. What is it giving me? 1 minus, right, minus, that's a sine 24 on its own. Why? Because sine 180 minus 24 is not minus sine 24, rather it is sine 24. But there's already a negative here that we factored out. So we still put it, it is still there. Bracket what? Bracket squared. Right? So we now square that. If we square minus sine 24 squared, we get a positive sine squared 24. But there's already a negative outside the bracket here. So it still affects our expression. So we end up having 1 minus sine squared 24. We go back now to using the square identity, and we say this is the same as cos squared 24. And apparently, since cos 24 is k, it means cos squared 24 is k squared. All roads, they still lead to Rome, can still arrive. There are many ways of doing one thing. Okay, so basically, I have explained in 2 different ways. Hopefully we can have one that we can get acquainted to. I know there are many ways again of doing it. Let it not confuse us. There are many ways of killing a cat. Right, so I advise though that you can just stick to one or maybe 2 if possible, but just 1 is fine. Okay, let's go to 3.2. Simplify the following expression to a single trigonometric ratio. Right, so we want to simplify that to a single trigonometric ratio. Right, starting with, I will not rewrite it, I will just explain directly the way where we are seeing it there, so that it can be understood right there and there. Starting with sine negative x. Sine negative x is similar to the situation that we just made right now. You say the sine negative x is the same as negative sine x. Why? Because it's found in the 4th quadrant. Right, so that's negative sine x there, times, right, we go to this one, x minus 180. X minus 180 is a negative angle. So since it's a negative angle, all negative angles, the easiest way of dealing with them is simply to add the 360 onto them. So we simply say x minus 180 plus 360, right? Times, we go again to sine 1 or 190. Sine 190 is now found in which quadrant? It's now in the 3rd quadrant. It's above 180 but below 270. So it's going to be written as sine 180 plus which acute angle? Plus 10. That's how it's supposed to be written there, degrees. Divided by, right, cos 360 plus x. Cos 360 plus x, this is now an angle above 360 degrees. It's greater than 360, which means it's found in the 2nd revolution. So all angles that are beyond or above the 1st revolution, what you simply do with them is you subtract 360 from them, so that they are now between 0 and 360, which means you are dragging them back into the 1st revolution. Right, so I'm going to also show that 360 plus x minus 360. So here is what to mark. Negative angles, add the 360. Angles above 360, subtract 360 from them until they are in the 1st revolution. Then cos 90 minus x. This is a reduction formula, right, of cofunctions. So cos 90 minus x is the same as sine x. So this is equivalent to sine x, by the way, right, times, we go again to cos 100. Cos 100 is the same as, right, it is the same as cos. There are many ways of expressing it. I'm going to opt for this one. I can say 180 minus theta, then I find the theta as 80. So I can write it as cos 180 minus 8. Or I can write it as cos 90 plus 10. There are many ways of killing a cat. So I will opt for this one, cos 180 minus 80. Right, because it is in the 2nd quadrant, mind you. So I said I can write it as 90 plus 10, or I can write it as cos 180 minus 80 as I have just done. Okay, so I'm going to write it as 180 minus 80, right? Then from there now, these are simplifiable. This is -1, by the way. There's no need to keep it. This is x. Sin x into sin x, that's 1. Sin x into negative sin x, that's -1. So I've already simplified that. Then I come to this one. If I say 1 minus 180 plus 360, I get, so of course here I now have -1 times sine, right? I said minus 180 plus 3, that's 180. So I get x plus 180, right? Times, I go to the next one, right? 180 plus 10, it is third quadrant, remember, and sine is negative in the third quadrant. According to the cast diagram, it is actually negative in that quadrant, in the second quadrant, in the third quadrant. So it's gonna be negative sine 10. Negative sine 10, because this is 180 plus theta, so it's negative sine theta, right? Divided by, we do the same thing again, 360 minus 360, that's a 0, so I'm left with cos x. And as a matter of fact, cos x is already simplified, right? Times, I go to cos 180 minus 80, it is the same as negative cos what? Cos 80. Why negative? Because it is in the second quadrant, and remember, in the second quadrant, cos is negative. So I have cos 80 there, okay? Then we simplify further. Sin x plus 180 is still found in the third quadrant, because remember on the cast diagram, this is theta, this is 180 minus theta, this is 180 plus theta. 180 plus theta is actually theta plus 180, so basically one and the same thing, there's no difference. Then this is 360 minus what? Theta. So I have -1 times that sine x plus 180, and that will give me sine negative sine, so negative sine x. Okay, that's negative sine x there we are having, right? Times negative sine 10, right? That's negative sine 10 divided by, right? I have cos x there times, right? This is negative cos 80. But from the look of things already, I'm making a forecast of where we are going ahead. We can see that this is sine x over cos x. We can cancel them, but of course, if they remain the way they are, we can end up applying the quotient identity on them. But can't we make sine 10 and cos 80 have a relationship? They can. Actually, using the reduction formula again, the same cos 90 minus theta is equal to sine theta, right? Understanding that. So we can target any one of them, either this one or this one. I'm gonna change the one that is on the numerator. So that's times negative sine x, right, multiplied by negative. So this is going to be, or it is actually the same as sine 90 minus 8, right? It is the same as that, sine 90 minus 8. Sine 10 is the same as sine 90 minus 8, right? I will just write this step here so that you can follow, but it's really not that necessary. I'm just writing so that we can really follow on what is happening, right? So it means I have, right, so I have -1 times negative sine x. So of course, negative times negative there was supposed to give me what? A positive, right? Times I have negative cos 80, right? Negative sine 10 is going to be negative cos 80 due to what I've just done there. I've applied the reduction formula for the cofunction divided by cos x times negative cos 80. So negative cos 80 divided into negative cos 80, that's a 1. Negative cos 80 divided negative 48 again, that's a 1. Then -1 times negative sine x, that's sine x. So I end up having sine x over cos x, right? This is what we now have. Right, so I tried to show all the steps down until we arrive here. How are we arriving there? So that's now a quotient identity that we are witnessing. The sin x over cos x is actually the same as tan what? Tan x. Hence, we have simplified up to the end. This marks our answer. Right, so we have arrived. That's basically what we are supposed to do. Right, so I'm going to explain the last question. 3.3, prove the identity cos x over 1 plus sin x plus 1 plus sin x over cos x is equals to over cos x. Right. For every identity, what you do is you will focus on the side that is more complex. By that I mean the side that has much to talk about. So in this case, you can see that there is much to talk about on the left-hand side than on the right-hand side. There's just one term there. There's one variable, so there's nothing much. So we'll focus on that left-hand side. So therefore, we are trying to simplify the left-hand side towards the right-hand side. So right, left-hand side here. So I want to rewrite the equation again so that we can move along. So it's cos x, just the left-hand side only, over 1 plus sin x, right? Plus 1 plus sin x over cos x. This is what we have, right, over cos x, right? We have two options. We can first find the lowest common denominator and we divide, or we can multiply both sides by that lowest common denominator. It's quite possible, right? I'm going to just demonstrate one and do the other one, right? So if I find the lowest common denominator here, it's cos x bracket 1 plus sin x, right? That's finding the lowest common denominator or the lowest common multiple. So I say 1 plus sin x divide into cos x plus 1 plus sin x. I simply get cos x. Cos x multiplying cos x, that is already there, plus cos x divided into cos x plus 1 plus sin x, I get 1 plus sin x. Multiply 1 plus sin x, I get 1 plus sin x multiplying 1 plus sin x. So it's the left-hand side. It's option 1. Option 2, I could have just done this. I take this denominator here, cos x. I multiply this side with cos x over cos x. Cos x over cos x. I take this denominator here, 1 plus sin x. I multiply the other side here, 1 plus sin x over 1 plus sin x. It's another option I could have taken, right? Then I now multiply cos x times cos x. I get cos x times cos x. 1 plus sin x multiplied by 1 plus sin x, I get 1 plus sin x multiplied by, which is 1 plus sin x squared, of course. Right? So I'm going to come to that stage. I just wanted to clarify clearly on this. I have seen quite a number of candidates who would usually have a little bit of challenge in simplifying that part. So it's good that we revisit our understanding, our knowledge of lower grades and employ it. It's needed now. Right, so here we are. It means we have cos squared x, right, plus 1 plus sine squared x over cos x bracket 1 plus sine x. This is where we are at. Then we want to simplify the numerator. So I'm going to expand cos squared x plus, that will give me it's 1 plus sine x bracket squared So from that expansion, I introduce 1 squared plus 2 times 1 times sine x, right, plus sine squared x. What are you simply doing? Square the two of them at the end, you square them. Then at the middle, you simply say 2 times the first one times the second term. You just multiply them by 2. Always, you have to multiply them by 2. So you are going to get 1 plus 2 sine x. 2 sine x plus 2 times 1 times sine x, we get 2 sine x plus sine squared x, right, over cos x bracket 1 plus sine x. This is what you now have, right? Then you can now simplify. Cos squared x plus sine squared x, that's 1. Because according to the square identity, cos squared x plus sine squared x is obviously going to give us sine squared x. That's basically a 1 there. So see that it means we have a 1 plus 1 plus 2 sine x over, I'm trying to show all the necessary, all the steps, not the necessary steps per se, but all the steps so that when you are following, you can really see what's happening. But if you are already seeing what is happening, even as I am adding more steps than necessary, good for you, then it's good, right? So here we are, 1 plus 1, that's a 2 there. So we have 2 plus 2 sine x, here we are, over, that's cos x. So we have cos x bracket 1 plus sine x. This is where we are at, right? Then seems we are almost there, but then we see a common factor there on top. What is the common factor there? It's 2. So we factor it out, 2. Factor of what? 2 into 2, that's a 1 there. 2 into 2 sine x, that's a sine x. We're talking of the numerator, over cos x, right, bracket 1 plus sine x. So it is usually at this last stage is where you can now be guided by the right-hand side to say, okay, how can I arrive at the right-hand side? So this can be simplified, 1 plus sine x into 1 plus sine x 1, 1 plus sine x into 1 plus sine x 1. I want you to see again the way I'm cancelling. I'm not saying 1 into 1, 1, 1 to 1. It's not supposed to be like that. Or sine x into sine x 1, sine x, you have to cancel it, all of it, 1 plus sine x 1, 1 plus sine x into 1 plus 1 sine x, you are getting also a 1. We are dividing, right? So, so we end up having 2 over cos x. There we are, right? So just like that, which means we have shown that the left-hand side is equal to the right-hand side. Therefore, it's equal to the right-hand side. We have shown that. So this is marking the end of our revision of our paper, right?